Geely has dropped the EX5 crossover in the spotlight. A four-wheel 90-degree steering system has been shown. The new steering system has been portrayed as a driving unit that means another step towards more development for the brand. The prototype was turned into a base for features of maneuverability, which go beyond conventional abilities of a vehicle. With such a steering system, EX5 can be easily spun on the spot, moved sideways in confined spaces, and controlled with high accuracy. EX5 was considered awesome. A demonstration video was released on December 12th. The self-developed driving unit was in action in the video. Motors were placed inside each wheel by the system. Traditional steering parts that limit the vehicle's movement were removed. Each wheel was being provided with a power source and a steering mechanism. Each wheel was enabled to operate independently. Its movement did not require other wheels. The video shows how the platform transforms the EX5. It was shown in the video that the platform can enable EX5 for movement in any direction within a limited space. The demonstration also showed the method of its external control. The prototype utilized the method. A glove was used instead of a regular steering wheel or interior buttons. Communication with the driving units was affected by the glove. The crossover could thus be moved from outside the vehicle. Its rotation into a desired position used minimal effort. According to officials, the development roadmap indicated that the glove would later be replaced with smartphone or smartwatch apps. Supposedly, it was to be replaced with smartphone or smartwatch apps. This would make such personal devices enable the control of the vehicle. It would have been possible to issue commands through such devices. A long-term vision had been expressed wherein advanced mobility features would become integrated with common digital tools. A merger of mobility functions and common digital platforms was intended. In the EX5 prototype, engineering architecture placed 4 driving units inside the wheels. Each of the wheels was made capable of turning up to 90 degrees. Each wheel could be turned in the same direction as the others or in opposite directions when maneuvering was required. It was enabled to pivot like a robot on a turntable by this design. The need for multi-point turns was removed. The sideways sliding or rotation until alignment in a parking spot was enabled. Time and effort in the course of parking operations were reduced for an SUV-sized model. The crab driving mode was introduced as part of this system. All 4 wheels were turned to an integrated position. Then, sideways movement along a straight line was possible. This mode was shown to be of help on city streets, residential car parks, and problem areas of loading. It was also pointed out by the engineers that on windy or slippery roads, this independent wheel system increased stability. The control software altered the angle and torque of each wheel separately in order to maintain balance. With all these merits, production scheduling for mass market production of the technology was not announced. The prototypes were equally forthcoming about the compromises that had to be made for urban tech. For one thing, the rear wheel arches had been enlarged for the 90-degree steering angle. Such structural alterations might have started to eat into the cabin area, shrinking space in the rear passenger zone. The prototype wore heavily tinted windows, disallowing any view of its interior during demonstrations. It was therefore speculated that rear seats had been temporarily removed, either to create space for test equipment or to allow the larger wheel housings. In any case, the perceived absence of the rear seats indicated that experimental conditions still prevailed regarding the technology. With no real prototype changes, the regular EX5 remained a colossal model in the brand's lineup. The EX5 is underpinned by the GEA modular architecture. Part of a strategic plan, it aimed at overseas markets as well. It measured 4,615 millimeters in length, 1,901 millimeters in width, and 1,670 millimeters in height. With such dimensions, the model fell into the compact to mid-size category of crossovers. It featured a wheelbase of 2,750 millimeters in order to provide a decent balance for drives that range from city ones to long ones. The single installation of an electric motor at the front axle provided an output of 160 kilowatts or 215 horsepower. The system allowed smooth acceleration with consistent delivery of power. It featured a battery pack of 60.2 kilowatts. This translates into a range of 430 kilometers or 267 miles under the WLTP testing condition. The EX5 is being posited as an efficient and accessible electric crossover for worldwide buyers looking to keep operating costs lower. It also has different names in different markets. In China, the EX5 took the name Geely Galaxy E5, which belonged to the Galaxy EV series. Prices were set between 107,800 and 179,800 yuan in a bid to ensure competitiveness of the model in the market. In Southeast Asia, the production was through Malaysian automaker Proton, which sold it as the Proton EMAS 7. The partnership helped Proton expand its offerings of electric vehicles, while Geely increased its reach into global manufacturing. The 90-degree steering system is believed to be a signal of intent of the brand to invest in advanced automotive technology. The concept is to create a boundary-pushing mobility model for electric vehicles, providing extremely correct and flexible movement. It is a big step in development, although there is still a lot of practical challenges with the prototype's design. Everything about the system points toward a future EV platform that will be able to negotiate cities filled with traffic with fewer driver inputs, making use of space more effectively. If this were to be applied to production cars, this technology might redefine how electric crossovers interact with everything around them. Parking, aligning, and negotiating tight spaces will be easier, especially in crowded city centers. What's more, smartphone-based external control may also bring new ways of car sharing, automatic valet parking, and personal mobility services. The improvements in the EX5 concept visibly signal an early vision of what could be the next step for EV maneuverability. Without an explicit timeline to reach market, that idea presages a future where electric platforms become extremely versatile, folding robotic-style movement ability into useful practicality. As it emerges, the EX5 becomes both an operating electric crossover, yet simultaneously a sneak peek at what the future will be like on the part of more flexible, digitally allied mobility.